What I've got on my bench today is a Grundig 495W tube radio, and this one's really something quite special. It's not only a rather early FM radio, which was built in 1950, it also has some of the same features as the higher-end AM radios from the time. The shortwave band, for example, is separated into 3 channels on this radio, making station separation and therefore tuning easier. It also has a coaxial speaker, with the tweeter being an electrostatic one. The other speaker here is a normal full-range one. And looking at the back, there is something that, in my opinion, is even more interesting about this radio. And that is that this radio actually uses predominantly steel tubes, which is rather uncommon. Those tubes were used a lot during wartime in Germany, but after that were essentially phased out rather quickly, and seeing those in an FM radio that was built as late as 1950 is something that's very interesting to me. This means that I am going to do everything necessary to restore this radio to make it work great again. Usually this only means replacing all of the old electrolytic capacitors, all of the old paper capacitors, and checking all of the components. Usually there aren't any major issues in these kinds of devices. But before I'm going to do any of that, I am going to test if the power transformer has any issues. The easiest way to test this is to remove the rectifier tube, plug it in, and check the power consumption. If the power consumption is what you would expect from just the heating filaments of the tubes together, then it's fine. If it's way beyond that and if the transformer gets really hot, then the transformer has an issue. Usually not the case, but I did have a few devices which had this issue, so this is what I'm going to check first. And also, by the way, the schematic of this radio is printed on the back side of the back wall. That's pretty neat, you don't really see that often anymore. The total power dissipation of the heater filaments inside of these tubes should be around 17 watts. By the way, while looking at the datasheets of those tubes, I noticed that most of them were actually released in 1950, so it doesn't seem like it should be that uncommon to see radios with these kinds of tubes. Maybe there are a lot more out there that I don't know of. Now that I know the power dissipation, I can test the transformer. Considering additional power losses due to the transformer, I would be happy with anything below 30 watt of power consumption. This is a rather crude measurement device, but it should be fine for this purpose. That seems to be about right. First step in removing the chassis is desoldering the speaker wires, and I also have to unscrew the magic eye tube. All of the wires are now free. I also removed the 4 screws that held the chassis in. As is rather common with these old radios, the front potentiometer knobs also need to be removed. Theoretically, I should be able to remove the chassis now. Should have removed the underside of the radio as well. I'll have to reattach that later. Those capacitors here, they look to be polystyrene capacitors. That's great because I don't have to replace those. What's also very interesting is that this capacitor here doesn't seem to be completely sealed. All of the capacitors I have ever seen were completely filled with some kind of sealant, but this one seems to have a rather large air pocket inside. There are some people that like to restuff old capacitors. Personally, I don't like to do that because at this point you don't really know if those capacitors are good or not. It doesn't look like too much work. Just this one, this one, this one, this one, this one, here, here, and there's one there. Oh, okay, there are. Okay, yeah, no, there are quite a few. I really want to take a look at this capacitor first of all before I do anything else. Let's take a look inside. There's something growing in there. It's definitely an old one. It just hasn't been sealed properly. Can take it out. It seems like I'll have to heat it up. Typical paper capacitor. Isn't too hard to do, and then you can just put a newer capacitor in there, recycle some of this old tar and reseal it up. However, as you could see here, this was a bunch of work, and personally I don't really feel it's worth it. Second pin. That's it. Obviously it doesn't look as original anymore, but to be honest, again, too much work. I have already replaced quite a few of the old paper capacitors with new ones. Some of them I will leave. For example, this one here is in parallel to a 50 kilo ohm resistor. If the paper capacitor here develops any leakage currents, it doesn't really matter. I have now replaced most of the old paper capacitors with newer metallized plastic foil capacitors. Also started replacing one of the electrolytic filter capacitors. I just put it in there. Should be quite stable. It does wiggle around a little bit, but it isn't too bad. Regarding general maintenance and cleaning, it's always a good idea to add a bit of some kind of lubricant in there to make those buttons work great again. I also removed the scale to make it a bit easier to clean the backdrop as well as the glass itself. And this is also a great time to replace the old incandescent bulbs. Coming back to the top side, there are also a few components to replace. Here's an electrolytic capacitor as well as two paper caps, the first filter capacitor, and here is also a sneaky paper capacitor that I want to replace. Take a look at that, about the same working voltage and capacitance, but 70 years apart. All of the capacitors on the top side are now replaced as well. I had to take a little bit of creative liberty replacing the 32 microfarad filter cap. I put 27 and 6.8 microfarad in parallel. You might not want to replace this with a larger capacitor. For example, I could have easily put 47 microfarad there. I do have a bunch of them. But the main issue here is that tube rectifiers have a maximum load capacitance at the first filtering stage, and if this capacitance is larger than the recommended one, you might end up with a tube that ages more quickly and you might have to replace it sooner than you would expect. In this schematic here, there still is a 150 ohm resistor in series to the rectifier tube, to those filter caps, so might not be that large of an issue. Still, it is better to use the original values in this case. Now, with all of the most critical components replaced and just clean, it is time for a first test. For this, I've hooked up this test speaker here, made sure to insulate the electrostatic tweeter hookup, and I will plug it in with only this current limiting bulb in series. If there is any kind of major issue, this light bulb will light up or stay lit up, and in this case I will know to turn it off as quick as possible. Ideally, you would want to use something like an adjustable transformer to ramp up the voltage slowly. Got the multimeter hooked up right after the rectifier tube, after the 150 ohm resistor, so I should get like 245 up to 260 volt. Okay. That's climbing rather slowly. There's something wrong. Maybe with the rectifier tube. It is quite definitely the rectifier tube. I have measured from before the 150 ohm resistor to the center tap of the transformer to eliminate any other components, and there is nothing. And measuring the output of the transformer itself, is fine. There's a bit of white powder in there, which seems to be remnants of the cathode. Luckily, Thomas, a friend of mine, had a replacement tube, so I can test it now. Oh yeah, that's way better. That's too much. Okay, maybe it will go down a little when the tubes warm up. Power consumption is still at 45 watt. Voltage is too high, which means that there isn't enough power consumption. As it turns out, the EL12 was also defective. The same cathode powder in there. Replaced it with one I had on hand. Still didn't work, although the supply voltage is now correct and the power consumption is closer to what it should be. The biggest issue now is I took a look at this tube here, which should be an EF12. Looks like an EC, right? Someone probably put this tube in place of the EF12, maybe to sell the EF12 or something like that. That's a bit disappointing, since this is another tube I do not have. But I do have a confirmed defective EZ12, which I can use to salvage the socket and adapt to a more modern tube, like an EF86, which should be compatible. I'll have to take a look at the datasheet. Just took a look at the EF86 datasheet, and the limiting values are the same and all of the curves are very similar, so I have no doubt that it should be compatible. In this case I will adapt a 9-pin socket onto this one and see if it works. For some reason someone already re-glued this socket, which makes it way harder to remove. Usually on these old tubes the sockets are already loose and just have to be like ripped off without using too much force. But in this case it's way too hard. I'll try to loosen it up with a wooden hammer. Oh yeah, that worked. Okay, now I should be able to clean up the solder and put some new wires through. By the way, it's fascinating that these wires here were insulated and the insulation has already just kind of worn through, so that's a bit concerning. Something like this usually really only works on older tubes. See this? Gets liquid. And that's it. This should be fine. The adapter is finished. I just used the pinout from the datasheets, connected those sockets together accordingly, and with this I can theoretically plug it into any socket that uses an EF12 and use an EF86 instead. It's working. Now that the electronics are working again, there is only one major issue still open, and this is the front cloth. As you can see, someone painted over the cloth for some reason. Not only is this very hideous, but it might also have some negative acoustical properties, since the speakers are now not really sealed, since there are still some air gaps, but looking at this, that's just unacceptable. The paint even got on the dust protection of the speaker itself. I remembered before I do anything stupid, I also have this foam cleaner, which should be quite effective at cleaning cloths. That's something like you would use for cleaning a car seat. So maybe this will dissolve the paint as well. I'll have to try. Okay. I wasn't able to document what I did because it was very hectic and I made a lot of mistakes. The cloth is now kind of clean, I guess. It isn't perfect. I just wasn't able to get it clean. First of all, I tried what's the recommended method for cleaning a radio cloth, and this is to clean it on the wooden panel without removing it first. This was a big mistake, since the wooden panel just absorbed all of the foam cleaner I put on the cloth, and it started to swell up on the edges, since this is just some kind of particle board. The damage wasn't too bad. I was able to react fast enough to put it on a heater and save the wood. However, now the front cloth started to just fall off. The glue was not holding anymore. This might have been positive, right, since I could now wash the cloth itself. And I started off by doing a very, very light wash without any kind of mechanical disturbing of the cloth itself. But this didn't help. I used laundry detergent, which didn't help. And after that I started to have to use a bit of mechanical force, just kind of rubbing my hands on. I started, folding it over and rubbing it onto itself, which didn't do anything. I used isopropyl alcohol and put it in a bottle of isopropyl alcohol for an hour, which didn't help as well. I started to use acetone. This did finally dissolve the paint. I mean, it did somewhat dissolve the paint. There is still a bit on there, but I did have to use some mechanical force, which caused the cloth to just kind of wear out on all of the edges. On the sides and the top, it isn't a big issue. There is more than enough space for those worn out edges to hide behind the wooden part. However, on the bottom side, the margin for error was not that big. Especially here, that's very bad. The cutout for the magic eye tube. This is the worst possible situation. That's horrible, right? The fabric shrank down quite a bit, which is a bit unfortunate, but I was able to stretch it out again by making it wet again and stretching it onto the piece of wood. Luckily, this also allowed me to bunch up some more fabric into the opening for the Magic Eye tube. It is not perfect and you will be able to see it, which again, very sad, but at this point this is everything I could do. Here it is back on the radio again. Looks pretty okay around the edges. Around the Magic Eye tube it is very noticeable, and also the lines not being straight anymore here. To be fair, it is to be expected with what I did to this fabric. I'm going to leave it like it is. At this point I'm not going to replace it with something else, especially since I can't even really find anything else. For next time I would probably not try to clean it at all. Wouldn't look all too nice in its original condition, but doesn't look nice now, so this was essentially just a huge waste of time. Chassis is screwed back in, speakers are reattached. Shouldn't forget to reattach the cable as snapped at the beginning. Very interesting. This bottom side here has a only very slightly conductive paint on it. Really not much. And now that everything is back together again, it's time for a final test. What a great station for this radio. My god. Since I'm in the basement currently, the reception isn't all that good. This might need some adjustment. I don't know, that sounds rather distorted. Ooh, that's bad. The speaker's got some issue. Yeah, the speaker itself is stuck on something. It just doesn't really move. That's not enough movement. Speakers of this type should move way more. That's it. And I don't think that's the pole piece, because I can push it a little further. It just kind of locks in after that. Luckily, this is one of those speakers that has screws holding the whole assembly together. You can usually take them out, take off the magnet, clean the gap, and put it back together again. Now, this is one hell of a job, and you can get things very wrong, but I've had to do it before, and it is possible. And in this case, I don't really see that there is a way around it. I was able to lift the magnet off very carefully using two flathead screwdrivers. Just lift it off like that. The pole piece seems to be very clean, no issues here. However, when I try to move the cone now, yeah, even when trying to move it symmetrically, sadly this is the part that I don't really have access to. The main reason why I cannot move this coil out of the way is most likely the spider, which you may be able to see in there. That's not like a normal, more modern speaker spider. It's just these little loops of material here. And I can unscrew the spider here with these screws. If I do this, I believe I can move the cone far enough for me to have access to this piece. This means I will have to flex the paper here quite a bit. I don't know if that's a good idea. But I will start with undoing the spider and see how far I can move it without any issues. Okay. Maybe I can also try to recenter it by undoing the spider. Maybe it's not corrosion, but a not perfectly centered spider in this case. I might be able to get away without cleaning it too much with any kind of abrasive material, but just recentering it. Also very interesting, there's a bunch of this golden color that doesn't really stick on neither the speaker nor the cone anymore. You won't be able to see it on camera, but there are a lot of chunks come off of there. I do believe that maybe those chunks were responsible for blocking the gap here. So that's a bit of an option, because now that I kind of moved it around and you know, tried to clean it out a little, it moves freer than before. So yeah, it really was just dirty. This paper is also kind of the perfect tool to clean out this gap. Really nice. I was able to get some paper which is even thinner than the printer paper I had, and I got this one all around the coil, so this should be nice and centered now. Retighten the spider. It still feels like it's rubbing, but you know, I might not be pressing it perfectly symmetrical, so I feel like this will be good enough. Since I do not want any issues in the future, I'm just taking a piece of paper, put on some silicone oil, and rub it onto the pole piece. This should just seal up the surface to prevent any potential rust from forming. Now you want to be incredibly careful when reattaching a magnet like this. Maybe use some kind of wooden ramp. You won't be able to hold it back just by hand. Okay, I got it now. Rotate it in place. Just carefully finish the rotation. Now comes the fun part. Centering the pole piece. Okay, I got it decently centered, and now for the final touches I'll have to do something like this. Just let the mass of it kind of nudge it in place. Had to do the rest with this wooden hammer here. Final test. Oh yeah. Perfection. Okay, that's way better. No problems now. Clean sound. Oh, I'm quite happy with that. Fantastic. Yeah. Okay. The result is very nice. It sounds amazing. That the electrostatic tweeter still works is also great. Overall, I am still quite pleased, even though the cloth didn't really work out the way I would have wanted. And it still was way more work than I would have wanted as well. But, you know, that's kind of the reason why I put this radio on the shelf for so long. If you like this video, like and subscribe. Leave a comment what you found interesting, if you would have done anything different with the cloth. If you do have some kind of replacement fabric, if you do know anything, let me know. But anyway, see you next time.
Every day it's getting heavier. The world keeps waiting.